So we're gonna have to, yeah, so this room, we gotta open this thing back then. That. So for instance, I think let's start here. All right, and then let's look at those two. No, I'm just excited to learn about the opposite. I'm excited. Yeah. So there's that one. What am I gonna do with this? Where's what is I guess. Words. Looks words. Plus 7x minus. Okay, tomorrow. Yeah. Have you done that? So, yeah. Or doesn't even. What do you want to do? Certainly displayed by them.
All right, so these are three that we form question. So we'll start with these, and that'll get us. The first reading I kind of gave you, so I gave you these two problems that had the same two parts, basically expressions they call it, but the same two pieces of 5x squared minus 4x, 2x squared plus 7x minus 6. What was the difference on these two questions? How's the answer? Yeah, so one's adding, one's splitting. So part of what I wanted you guys to do on this question is just again to remind you the difference. In terms of, variables. So what did you guys get for the first part? This is all your discussion questions. Oh, it's interesting. And why do you say 10x? Yes. Let's say if we're adding, we're combining like terms. What is combining like? So yes, that's gonna be 7x squared. Plus. Negative 4x plus 7x, which is 3x. Whatever. Minus 2. And minus. Then what did y'all do when you had to multiply these? Different operation, different action, what did y'all do? And x. And how did you get the 10x difference?
You just apply the number in front of the x together, then you add the two exponents.
Good. Okay. And then what else did you get out of that?
Like you want the final answer or how I solve it?
Yeah, how you solve it, yeah.
So at first I got 10x to the 4 plus 35x cubed. Because I times just 5x squared times 7x.
Yeah.
So the two exponents plus x.
Give me, you're right, it's fine, sir. Keep going.
Now with x cubed
Yes.
minus 30x squared minus 8x minus 28x squared plus 24 things.
Plus 24. And so what we're doing here is off distribution. So anytime you're multiplying in, unless you're doing numbers, basically. Anytime you're multiplying in mathematics, you're doing distribution. So then, keep going. What did you?
Simplify, I got 10x plus 27x
Yes.
minus 58x squared plus 24x.
Plus. So, and for the stuff I'm gonna do debate today, depending on how you guys run through it, so this is gonna come in a huge one. So depending on how you do it. But so just remembering that addition is combining like terms, multiplication is distribution. Notice they're really two completely different things. The discussion I gave you guys that would, that was the one that was for today. I wanted to remind you guys about basically substitution, about plugging into a function. So if I give you this function and ask you to do f of -4, somebody else take me through, how would you do that? Yeah, well, so that, they're literally replacing x with -4, so that tells you. Plug in -4 or replace -4 for volumes. It's -4 squared. It's 3 times -4 plus 7. And then what happened back? We're gonna use, like I said, depending on how we do the problem, so we're gonna use this account today. Problems, we're like. Any questions on those results for anybody? Then what we wanna talk about is. So you can see these problems where they give you 2 or more functions, but we at least need 2 of them. And then they're gonna ask you to do operations or to do things with these functions. So you'll see they're gonna ask you to add, you're gonna ask you to multiply, subtract, divide, and then we're gonna learn one new type of operation today. You can't do just numbers by themselves, called function calling. First, let's say I give you these 2 functions. They're gonna ask something like this, maybe f plus g of f plus g of negative. So at least that's the way to read. So f plus g of negative. So notice that we have basically the same little function notation of a function here with -3 being placed for your x. So I guess where I want to go with this is when you see this, what do you notice? What's familiar? What are they asking?
It's just like you're finding the f of 3 and g of 3 and then you add them together. It's actually 2 separate functions.
Okay, but not treat it as 2 separate functions, where you're adding them together. Okay. What else? Does anybody do that differently or? This is one of those, like, I don't want you guys to assume because dude, he usually gives right answer, said it, like that's the right answer, so I'm just gonna absorb the right answer and run with it. I really am actually asking, how do you read it? What does it read to you? Because there's 2 or 3 different ways to read this that all give you the right answer. So you don't need to read it the same way that he did. So how does it read to you?
Do you add both of the equations and plug in the negative to the x?
You could also do that. So I'll circle back to both y'all's answers, but for the rest of y'all, how does it read? I gotta get you guys, you gotta play your head like a video on YouTube or something like that. Like when you're thinking about things, you should always be watching what you're thinking. Figuring out kind of how you're seeing stuff. Because it helps you actually learn, it helps you actually think. But then you can sort of analyze, okay, what's good about this, what doesn't work about this. So the two ways that they mentioned are the two different ways, or three different ways you can do this problem, but I have to say the two main ways that you can do this problem, kind of see. One way you can do this problem, so when I look at this, the thing is, when I look at this, what I see is addition and I see substitution, I see plugging in a -3. There's two main actions. And so you can do these actions in any order, so we can either add our two functions together and then plug in a -3. But like we just saw, like we just saw on the reading. Or you can plug in a -3 to each of these. And you'll get some result out of that, and then you can add those results together. And what we, personally, which way do you? It depends on, it actually depends on which ones, which question, yeah, so for this. I would probably add them together first and plug in a -3. But if one or both of these was like the square root or an absolute value or something like that, then I would do it individually and. Yeah, so. The way I do math is mathematics, I'm really a gamer. So my thing is that there's two equivalent ways to do things. I learn both ways. Then for each problem, I pick I try to figure out what's the most efficient, best way to get to the. So I'm really much more of a gamer. I rarely have one way that I use. That I prefer for all problems. So we can approach this either way. So as we're doing some of these problems, I want to kind of highlight both ways, but also the part of your goal today is just figure out which way works better, which way like more natural, like looking for it just more natural. And whichever that is, run it, like major on it. You're gonna get the same answer either way. So, so to work this problem. Showing it. Well, I'll highlight the first method that you mentioned. So one way to do this is f of -3, is cube -3. Oh, also, sorry, to further answer your question is, not only does it depend on the equations, it actually depends on the operation. So there's some operations where it's easier to take your approach, and there's some operations where it's easier to take this approach. So I'm lazy. I will do all the thinking beforehand because I'm always just looking for what's the. But so let's highlight this one. So I'm going to figure out f of -3. I'm going to figure out g of -3, and then it tells me to add the results. So that's what I'm going to do. So let me give you guys this to do that if you know that. So a lot of people already started on it. So go ahead and work that for a minute. This class. So for the f of -3, that part, what did you guys end up getting? So -3 squared. Is 3 times -3 plus 5. That is gonna be 20. That's a 9 plus a 9 plus 5. Plus whatever we get from g of -3. What did you guys get from g of negative? Yes. 7 and it's 7, which is 11. And was 23 plus 9. So f plus g of -3 is 42. So, really quick to kind of go there, I like the second way to do this. So the second way to do this is to add the first and plug in negative. So if we did that, we're doing x squared minus 3x plus 5, -4x plus 7. So just thinking through this, what is this going to give you?
And it's x squared minus third x.
Yeah. Those combined, so we get x squared minus 7x
Plus what?
plus 12. And then what we're going to do is we're going to plug in -3. -3 squared minus 7 times -3 plus 12. And the fun thing is we're going to end up with the same answer. So that's -3 squared is 9. Well, yeah, good. -7 times -3 is 21 plus a 12. 9 plus 21 is 30. Yeah. 9 plus 21 is 30. 30 plus 12 is 42. So it doesn't matter how you do it, you get the same answer. You just have to do those two things. You have to add the results or the functions and you have to plug in. At least for this problem, just like this is your first bad, first attempt at it, which feels better for you personally? Like first attempt plugging in and then adding. How many feel better with that? And then how many feel better with adding? Well, so I think, like as we do these problems, I kind of can't do each one two ways. So I'll probably major on this only because usually for this level of class, this is kind of, most people prefer this method. It just, it's procedural and makes a little more immediate sense of this. So, but just so if you're one of those that like the other way, just do these problems. Thing.
I never knew equals to
The other, yeah,
but like you said, it gets difficult with everything else. But
yeah. Honestly, yeah, like we're multiplying these, you're gonna spend 5 minutes first. So it ends up simpler. So yeah, that's usually for addition and subtraction, I would take the second way, but for multiplication. All right, so let's do, that's adding two functions. Let's say I want to do g minus f. do G minus F of two. So we've got two things to do here. We've got to plug in the two, we've got to subtract. Or again, you can do it in reverse order. You can subtract the two functions and plug in the two. But either way will get you to the same answer. So I'll have you guys work on it because hopefully what you see is, I mean, this really, no matter what the operation is, this is the same thing. So that the first part of this homework, the majority of this homework, they're trying to get you guys comfortable with, you already know how to add, subtract, multiply, and divide, and you know how to plug things in. So actually, none of this, not teaching you anything new here. They're just asking you to do it with this little notation. So go ahead and take a couple minutes and work through G minus F of two. Okay. That's good. Yeah, no, I didn't. All right, so let's see what you guys are getting on this. So again, like I said, I think G is the majority kind of favor this approach. I'll take this approach. So we want to do G of two minus F of two. Plug in the two and subtract. What did y'all get for G of two? So that should be -1, -4 times 2 plus 7, that is a negative. And what about f of 2? Yeah, I think that's about right.
What do you have? What? What is it?
2 squared minus 3 times 2 plus 5.
I'm thinking.
So that's what, 4 minus 6. So actually 4 minus 6 plus 5. So this should be negative 2 plus 5, which is 3 actually. And then we want to subtract those, so negative 1 minus 3. And what does that get you? Still plus negative 1. Their answer there should have been negative.
Roger just what is it?
That's right.
Just do the breakfast. I was gonna do it like. I was adding the count. It's just like each one. I was in the middle. We had to.
Let's do something like this. So we'll just kind of do the next oscillation. They're gonna ask you to do f times g of negative 1 or f g of negative 1. But it's the same deal. So honestly, all these are the same deal. They're gonna tell you what to plug in, they're gonna tell you the operation to do. So this is gonna be f of 1 times g of negative 1. So let me give you all 2 to work on there. Yes, well. So we'll do this, and then let's do. This is gonna be G over, so when they want you to do division, they'll write it as a fraction bar for the G over F. Yes, let's do G divided by F or G over F of 7. Oh. I don't know if you get. Sit down. Yeah, this is where we have it. Let's see, where are we on time?
There. So probably to experience, but you. Last. Once again. I think. I think. I have with them.
Let's see what you guys got on. So F times G of -1, somebody take me through how you did.
First, wrote the function as a maximum, and looked at -1 for,
Yeah.
so -1 squared. Minus times. We'll get one, plus 5.
-1 squared minus 3 times minus 5. Good.
1 squared, just 1 muscle, and the negative times the negative, positive, so
Yes,
times 1 is 30, that's 5.
yes. Good. So that is a 9. And then, yes, we need to do G of -1.
-4, 5, -4.
-4 times -1
Plus that. And then the same thing if with positive,
yeah,
plus that equals 9.
4 then, or
10. We let it.
yeah, there you go.
And
Good,
then you just multiply with,
and we multiply them.
since you said that times. And again,
Yes, that is 90. So you should have got 99. Alright, so any issues that y'all are having putting this together? Calculations. And then somebody else take me through G over F of 7.
Like you talking about.
Yeah, that's a good way to. Get to the big one.
Topic on negative community study. On about 49 things.
Mhm.
And that was.
Yes. So she, oh, so that actually should be on the bottom. 7 squared plus 3 times 7 plus 5 times 12. I'm working all this out, would have been made 21 on the top. And 33 on the bottom. No, for fractions, if you can simplify them, they're never gonna say the word simplify anymore, but if you can simplify them, you have. And probably about half the time you can. So can we simplify this? Privately, it kind of looks like you can't, it could be odd numbers, and they look like maybe they're fine, but privately you can. Yeah, you can divide both by 3. So this goes down to -7 plus. That's right. Give me a second. All right, any questions or any issues there? Do this really quick, hold on. Okay. All right, so then, like I said, there is another operation that you never be able to do, number. So this operation is called function composition. But, so their word composition that they're using here, so in theoretical terms, it makes a little more sense. What they really are trying to say is substitution. We're gonna substitute sort of one function into another. We're just gonna use a bunch of substitutions. We're kind of involved. The way they're gonna write this, so we'll use the same 2 functions. They're gonna, you'll see something like this. So F compose G. So it's smaller than an O, and a lowercase o, but bigger than a dot. An open circle, basically. F compose G. And. Else. I'm just on here, buddy. Well, let's do F compose G. Now, like I said, what this means is substitution. Or plugging one function into another. So when you get this, what you really want to do is we're going to rewrite it by kind of what it means. What this means is F of G of 2. So there's a couple different ways to visualize this, and I want to figure out as we go which way works better for y'all. But this is what it is. So we're going to do G of 2. And then, so this is literally working from inner parentheses out. So we're doing G of 2. And then whatever that result is, that becomes what we plug in ahead. Whatever you get out of it. That means the first thing you gotta figure out in the problem is what G of 2 is. So how would you figure out G of 2?
Oh, like,
Yeah, what?
the negative times 2 plus 7.
So, yeah, there you go. Yeah. Just, let's do this G of 2. If you, let's say 4 times 2 plus 7. What does that get? -1. Yeah, that gives you -1. So now that -1, now we're gonna plug that back into that. So now we're gonna do F of negative. And how do you do F of negative? Look at it. Okay, just off this sheet. So this is -1 squared minus 3 times -1 plus 5. Yeah, and this is gonna end up being 9, and I already did the calculations. And that is our x. After post g of 2 is 9. Again, notice it's all pointing. So here, there's no add the results, multiply the results, whatever is. One of the fun things about function composition, so we can turn this process backwards. But unlike most things in mathematics, when you turn it backwards, you almost always get a different. So when I do G compose F or, G compose F, and we're gonna do this at 2. So put in the same number in, but notice this time you're putting 2 in the F. So this is gonna be G of F of 2. You're at F of 2 first. And notice that that's a completely different thing than we did for the first, so really just not this. Oh, good. You guys are already working on it, so take a minute and figure out. Decompose that. So one here. One. You would have. All right, let's go again. So what did you get for F? Let's work it through. So f of two is gonna be what, 2 squared minus 3 times 2 plus 5. So that is 4 minus 6 plus 5, and that is gonna be positive. And then we get to plug that now back into G. Now we're doing G of 3. And what G of 3 is gonna be -4 times 3 plus 7, and what did y'all get? 7, which is one. It's need to bulk numbers, right? -5. Same input, really different. There's- Need to do that. Any questions or issues there? But then what I wanna do is I'll give you guys a different set of functions and have you do. Probably do like, so same thing, just kind of like work through and do all of these, or at least a lot of these. So we'll do that with 2 more functions, 2 more equations, and then we'll also do it with functions that are graphs. So just gonna do this 2 times. Alright, so I'll have you guys do those polls.
I am. Class out of people are. Shoot, so tight.
Hey, Bobby. These Surrender. Oh, sorry. Two. Yes. All right, let's take a look at what y'all got. Probably go through less of the calculation this time. For it, but G minus F of 7, somebody check. Okay, so we want G of 7 minus F of 7. What did you get for Q's? 7 minus 5. Absolute value, then so. That is 13. That's gonna be 16. And then what about F of 7? I mean, which is, you got again, 7 plus 2 is 9, square root of 9, and subtract those, so what did y'all get there? So that's gonna be good. That's what you should have got for part A, but. So for part B, we're doing F of 2 times G of 2. What did y'all get? Good. 2 plus 2 is 4, so the square root of 4 is 2. For G, that is gonna be the absolute value of 3 times 2 minus 5. Absolute value of 1, which is a 1. That was not 1. Yeah. Our answer there would have been 2. Then for F composed G, trying to do here is F of G of 4. So On the G of four, somebody take me through how you did the parts.
Four for G.
Yeah, plug in three for G. Absolute value of 3 times 4 minus 5. And what did you get for that?
So,
12 minus 5 is 7, the absolute value of that is just 7. And then take it from there, what'd you do?
so. I,
And that is the square root of 7 plus 2, so what did you get out of that?
3. The last problem, you had already solved for it, you said it was back to
Sure, yeah, you could just reuse the answer that you got, okay. So
It's the same thing with B.
same thing with T. Okay. So you're saying, so it looks like, yeah, we're trying to do G of F of 14. So we start with F of 14.
Or the fourth of those,
Yeah. And what do you get out of it?
16.
Yeah,
And then which is 4,
which is 4, yeah, so square root of 16, which is 4.
and then solve for G. We had solved problem in part C.
Oh, I see. Yeah, we did already figure that out then. What's that? Yeah, so that is just a reset. Good. Any questions or any issues there? So let's do this one more time, but this time we're gonna do it without equations. So we saw last couple weeks, sometimes, most of the time when they give you functions, they're gonna give it to you as equations. Sometimes they'll give it to you at the table, but more often as a graph. So sometimes you just give it graph. So let's see. Function is. This will be N. Something like that, that would be G. You can do some of these things. Let's do.
I'm gonna break it down into two pieces now, but.
So they may want you to take these and do G plus F2. And I don't have an equation, but this is actually even better. So I have the graphs before me. So I can figure, this is still the same thing. It's still G of 2 plus F of 2. Now I just use the picture to tell me the Y values. So based on this picture, what is G of 2? -2. Yeah. So looking at G, this function at 2, you go down and the Y value is -1. So this is that same thing you guys did literally that first week in second, just reading off the graph. So G of 2 is -1. What's F of 2? 2. What's -1 plus 2? 1. And you got it. You're just reading the Y values on the graph. When we were plugging all this stuff into equations, you also gotta remember, when we're plugging this stuff into equation, that's really what you're doing with the equation is telling you the Y value. So you don't need an equation for a Y value. If you have a graph, you still have the Y value. So that means part B here is just G of -1 or F of -1. And what is G of -1? Two. G of -1 is -2. What is F of -1? +2. And what does that give you? You're subtracting 0, or you're adding a 0. What's -2 divided by 2? -1. Yes. And yeah, just because I won't have the time to kind of send you guys through the problems and come back, so. So then F composed G of 0 is still the same though, it's still F of G of 0. Now we just get to read all that off the graph. So based on the graph, what is G of 0? That wasn't what I wanted, but that works. So G of 0 is 2. 0. Actually, no, sorry, it's not 2. It's not. So F of 0 is 2. What is G of 0? -1. That is -1. And then now let's go to F. What is F of -2? Yeah. That's it. And G composed F is G of F of -3. So using our graph, what is F of -3? -3, F is -2. And then what is G of -2? So on G at -2, my point, Y value is +2. Anything odd about those for y'all? All right, that'll knock out this week's homework for y'all. Remember that next week we have a test, so we'll review on Tuesday and we'll take the test on Thursday. It's by hand, though. I'm just gonna pack this paper. Yeah, yeah, but, yeah, about everything we've kind of learned so far, yeah.
No, no, what? I don't know if. Take on, look.